Good morning and welcome back to Sonnet Institute of Technology. My name is Bruce Malauti and I'm an instructor for the Pentesting video course. This is module 4.4 and we are looking at ways in attacking data in motion. Plain text protocols such as HTTP, FTP, telnet, they are vulnerable to attacks such as man-in-the-middle, sniffing, packet capture, or even replay. To analyze packets, you use tools like Wireshark. You can use tools like TC dump, and in this case I'll be using Wireshark for the demonstration. In this demonstration I have two primary goals. I need to capture conversations on one will be using a plain text protocol, and then the other one will be using secure protocols. So I will have two exercises. So the first exercise is to compare between telnet and SSH. So we'll capture packets on a telnet conversation, then we'll capture packets on an SSH conversation, and then we compare the two. In the second exercise, we will compare between secure web server, which is HTTPS, and a standard or normal web service, which is HTTP. So without wasting time, let's get to the topology and start configuring. So here we are back on GNS3 on our topology. I have a telnet client here and a SSH client here. Then I have a SSH server and telnet server over here. Okay, in GNS3 you can start Wireshark by right-clicking on the target link. So in our case, we need to capture a conversation between this telnet client, a Windows 7 machine, and a telnet server, that is a Cisco router. So I can right-click here and then select Start Capture, and I can choose or select the link and click OK. Wireshark will load. So Wireshark has started and you can see a lot of packets are coming through, and these are spanning tree packets or STP, which are used by switches. So I can minimize this as it captures in the background. And let's visit the Windows machine. Okay, here I'm on a Windows machine and I need to telnet to the target system. So I'll double click, select telnet, enter the telnet server's IP, and log in. I'll log in as Lisa, enter my password. Now since I'm logged in, I can do a bit of commands such as show IP interface brief. So this is a Cisco router. And can I escalate my privilege? That will be enable. It's asking me for password. I can enter the enable password. Now I am in privilege mode. So if I do show run, I can see all my running configurations. So I can exit from here. So I've ended or stopped this telnet session. So let's go to Wireshark and stop it. Stop Wireshark. And let's have a look at our packets. And before we scroll up and down, you can see we got our Wireshark, our telnet packets here. And you can see the source IP, it's a .10, that is a Windows 7 machine. Destination IP is a .1, that is our telnet server, and it's a Cisco router. Now if you scroll down to here, you've got packets which are broke down into different layers. We've got layer 2, layer 3, and layer 4. And if you look closely here, you can see we even have our port numbers on the layer 4 of the OSI model. So we've got destination port is port 23, and we know that telnet is port 23. So the question is, how can we tell that this conversation was secure or plain text? That is easy. You just select the packet which we are interested in. So in this case, we are interested in telnet. I can select this one or that one or that one. It doesn't matter. Once you select the packet of interest, you right click and then you scroll down to follow TCP stream. And there we go. As you can see, if you scroll from the app, when we telnet or we initiated a telnet session, we were asked for username. Username appeared as Lisa. So you might be wondering why you have double characters. It's because of reflection. So the username is Lisa, and then the password is Red Hat. Now the user also entered some commands, so you might see some repetition of characters, but the commands were show IP interface, BR, which is brief, and then this was the output. And then the user also did an enable command. The user was asked for a password, and the password was Red Hat, and the user escalated the privilege. Now is in a privilege mode, and then the user also passed the command show run. So if you scroll down, you can see the running configurations of the Cisco router, and we can see the passwords in plain text and so forth. So this clearly shows that telnet is not secure, and you can see that we are seeing the passwords in plain text, and yeah, that's how telnet and all other plain text protocols operate. So let's jump over to a secure protocol such as SSH. So we will do the same. The same user will SSH this time to the same Cisco router and pass the same commands and see if we can see anything from there. Okay, so back on the topology, and this time I would like to SSH from SSH client to SSH server. So I will repeat the process and right click on this link and start the Wireshark. Once Wireshark starts, I can minimize the window and get to a SSH client, which is my Windows machine, and let me log in. Okay, so let me start SSH this time. So that will be 192.168.15.1 and start our SSH session and accept the key warning. So I'll log in as user Lisa, and the password. Okay, so the user is logged in, and I can do the show IP interface brief command. We can see all the interfaces. I can do the enable to escalate my privilege. So now the user is in privilege mode, and I can do the show run. Alright, so I can exit, and then I can close this as well and stop Wireshark. Okay, so let's look at the conversation. We have SSH conversation here, and our client is, or can I say the source is 192.168.15.20, which is this machine here. And then we got our SSH server, which is a .1 right here, .1. So to see the payload, I just have to right click and go to follow TCP stream. Now, can you read what's in here? No, you can't read. Does it make sense to you? No, it doesn't make sense. Why? It's because the data is encrypted. Encrypted data cannot be retrieved without the key. So as you can see here, data has been encrypted, and you can see the methods used to encrypt data. We have AES, which is Advanced Encryption System, and then we got algorithms such as Diffie-Hellman, as you can see here, and then we also have hashmark, SHA-1. We also have the RSA. There's a lot that happened here, but as a matter of fact, this is useless to us, and we can't do anything. Even if you are trying to do man-in-the-middle attacks, this data is useless and it's meaningless. So this is how a telnet and SSH differ in how they operate. Telnet is not secure, and we saw that the conversation happens in plain text. We saw the usernames, we saw the passwords, we saw the commands that have been used. Whereas on SSH, we can't even see a username, we can't see the passwords, we can't see the commands. We have nothing. So this is the end of exercise 1. So let's go to exercise 2, where we will test on HTTP and HTTPS. Okay, in exercise 2, we have HTTP server over there, and there is some confidential files on this server, which is meant to be accessed by a user, Lisa. So this user, Lisa, will demonstrate using HTTP, and then we'll also demonstrate using HTTPS. So in both scenarios, we are accessing a confidential file that is stored on this server. So we'll repeat the same process. I'll right click the link and start Wireshark. Once Wireshark loads, I can minimize the window. Minimize. Okay, Wireshark has started, and I can see the packets are piling. HTTP, which is spanning tree protocol, so I just have to minimize that. Now let's log into the HTTP client. Okay, now I'm logged into the HTTP client, so I will start Firefox and navigate to the confidential file. That will be HTTP, the IP address of the web server, and the complete URL, that is where the confidential files are kept. So I'm asked to log in, so I'll log in as user Lisa and enter my secret password. So the user is been authenticated, and the user can also read the files or the information provided, as you can see here. So we can close the Firefox window, and then we can close this as well. Let's go back to Wireshark and stop Wireshark. So let's look for HTTP traffic. So the destination is a .30 right here. Sorry, the source is .30, and then destination is a .250. So as you can see, I have the handshakes and all that. So here we go, HTTP traffic. All right, so what you can do now, we can follow the stream and see if, because this is a HTTP is a plain text protocol, so we should be able to see the passwords and the data which Lisa was trying to access from the remote server. So if you scroll down and scroll down, down, and you scroll right there, can you see yeah, there we go. If you look closely, you can see exactly where the user was trying to go to. As you can see, the user was trying to reach HTTP, the IP address of 192.168.15.250/secret, and then scroll down, you find that the password is hashed, but the entire information, if you scroll here, is in plain text. So the user Lisa had information, confidential information on the remote server. So when she accessed this information, is passed in plain text. As you can see, this is the information we saw on the web browser. So if you go back on the web browser, go back to HTTP client and start our web browser. HTTP 192 /secret. Okay, let me authenticate again as Lisa, and the password. Okay, so this is the information which we are seeing in Wireshark, and this is the web browser Firefox. So the same information here is the same that we see here, right here. Alright, so this proves that HTTP passes the information in plain text, and things like passwords and username can be passed in plain text as well. So without wasting time, let's go to HTTPS and try to reach the same confidential file and see if we can read the contents. So I'll close that. Okay, now we will try the HTTPS client. So we'll repeat the same process. Right click on the link, start capture. Once the capture begins, you can minimize that window. The capture is begun, so we can minimize this window. Go to the HTTPS client and log in. Okay, so I will start Firefox, and this time I will use HTTPS instead of HTTP. Enter my IP address of the remote server and the location of the confidential file. Okay, so we are presented with a warning. That's a digital certificate warning. So you just have to accept because it's a self-signed certificate, and then confirm. So I'll log in as Lisa and enter my password. Okay, so as you can see, we can access the file, and yeah. So let's exit from here and bring Wireshark. Okay, so Wireshark is still running, so I can stop it. Stop. So let's go and find HTTPS. Okay, so there's a lot of conversations here. So we got this one here, which is using TLS. That is our secure web server conversation. Source IP is .40, destination is .50. So if you look from our topology, source is .40, and then the destination is .250. So let's try to follow the TCP stream. Okay, so if you look here, we have no readable information. We can see that the user has visited ipaserver.com. That is the host name of the IP of the host. The host name of the web server. Our web server is on a .250 IP. So this is the host name. But can you see the entire conversation? I don't see it from my side. Let's try to follow another TCP. Let's follow it. Another one. There is another one. Do you see valuable or juicy information from here? No. Let's scroll. And so what I have here is we cannot see any information because HTTPS encrypts all the data and there's no juicy information here. So we can't see the bank account, we can't see the account number, we can't see the national ID number as we saw in the previous demonstration. So HTTPS is secure. So if I were man in the middle, the only information I would have got was the host name only. So I can't see the passwords, I can't see the information which Lisa was accessing this information here. You see the bank and account, national ID number and all those. So let's conclude this exercise. In this exercise, we had two exercises. The first one was to compare how you can reach a remote shell securely. So if you use telnet, you are on the risk of many Migo attacks, but if you use secure shell, you are safe because secure shell uses encryption. And then on the other side, or the second exercise, we had a web server over here, and we found out that HTTP uses plain text, and we could read all the contents of the conversation, including passwords and username. But HTTPS encrypted the payload. We couldn't see the secret information which this user was retrieving from the remote web server. So the motive of this demonstration is to show you the importance of encryption. Encryption is very important, and please use encrypted or secure web applications to retrieve web resources. I would like to thank you for watching, and I'll see you in the next module. Goodbye for now.